and welcome to a brand new video series brought to you by PH Studios, and what we'll cover in this series is C++. The first thing I'd like to talk about is a brief overview on what the series will cover. It'll cover quite a bit of things. It'll cover basic C++, object-oriented programming, loops, methods, also known as functions in C++, decision statements, those are the if and switch statements, output, that is stuff that'll be printed to your monitor, sent to your sound card to print to receive it to the speakers. Uh, Sent to your printer. That's all output. Input is keyboard, mouse, microphone. We'll talk about includes. Then the three object-oriented programming principles: inheritance, encapsulation, and polymorphism. We'll talk about classes, object pointers, and finally Windows programming. Let me reposition my mic. Okay. So what this specific tutorial will cover: what is C++? What is object-oriented programming? How do programs work? How to use and what are includes and using statements? We'll cover how to use them later on. Output, hello.cpp refers C++ program. What can be an expression in statements? So what is C++? C++ is a very powerful language, pretty much the most used for gaming, and it's been around for about 20 years. No other language has been able to match its speed and power. But while C++ is not as good as assembly, it is the most common powerful language most people use. See, what the compiler does is it compiles the C++ code into assembly code, and that compiles into machine code, which is zeros and ones. So everything C++ is the highest level language other than assembly, because assembly is the most powerful and fastest and hardest thing to use. Most computer software are designed in C++, and most operating systems are designed in assembly if they're wise to do so. They can do it in C++, and that's okay, but assembly will be faster and the best way to do it. So if you decide to write programs, C++ is the most powerful and best way to do it. Always remember, if you're interested in starting programming and you're interested in C++, I recommend you stop now and go learn C# first, because you need to learn something a lot like C++, but not with the highest confusion level that C++ has. C++ is special in that it supports multiple programming paradigms, including object-oriented programming and procedural. Procedural simply groups a program into operations that are performed. These terms will be more explained later for object-oriented programming. What is OOP? Object-oriented programming, or OOP, is a paradigm that organizes your application into objects that interact with one another to accomplish a task. With OOP, you can make classes and objects of classes in your program. Later in the tutorial, we'll have a look at polymorphism, inheritance, and encapsulation. But just to give you a definition of these, polymorphism is something that adds to a different class. So you have a class and you want to make a new class, it'll add something to that last class without writing everything in and adding one line. You can use polymorphism. Inheritance, think of that as like your parents to you. You inherited certain stuff from your parents, but you also got your own traits. So a class will inherit a different class, but also have its own traits too. And encapsulation, we'll be doing that the most in the first 10 or so tutorials. Okay, okay, never mind, we're not in classes yet. Okay. How do programs work? Programs handle the three functions of computers, which are input, output, and process. Input consists of stuff like keyboard, mouse, microphone, and scanner. Output consists of stuff like monitor, speaker, and printer. Process. Process branches off into two tasks, known as compute and control. Compute has three features known as arithmetic, logical, and relational. Arithmetic consists of addition, subtraction, multiplication, division, and modulus. Logical consists of stuff like and, or, not. And finally, relational consists of stuff like greater than, less than, equals, or not equals to. Note the equals here. It has two equals signs. So that is the relational operator that will compare two things to one another. Compute. Oops. Okay, compute. Compute branches off into the four primary programming logic constructs. These include sequence, decision, loop, and unconditional branch. Sequence is just a computer performing your code in sequential order. Decision consists of stuff like if and switch statements and will execute different parts of the program depending on the Boolean value. Loop consists of a while and for loop. This does exactly what it says. It loops. Unconditional branch consists of the go-to statement. Using this is never recommended. Okay, now let's talk about the code. You will get Visual C++ 2005 Express Edition, but I can't get that because I have the Visual Studio 2005. And it'll mess all the things up. So, basically, once you install that, once you install the SDK for it, you can run it by doing File New Project. It'll be a little different. This menu will be a little different from yours, but if you need any help, you can ask. C++, we want to create a Win32 console application. We enter our name as Intro to CPP. Okay. It'll go for that. And we want to do this. Okay. It's been a while since I did this. We compile it, make sure it runs. F5. Yes. Okay, it runs. So we got everything going. So now let's walk through the program. Ignore what I'm typing here. Okay. Okay. Now let's walk through the program. At the very beginning, you'll have comments, and we'll go into comments later, but at the very beginning, you'll have includes. What are includes? Let's go back to the slides. Includes. The first two lines of code show a pound or number sign, which is a signal for the preprocessor. The preprocessor's job is to look through the code for pounds or number signs, and when it finds one, the compiler modifies the code before it is fully compiled. Include is a preprocessor that tells the compiler that what follows is a file. Then the compiler finds the file, reads it in right there. So basically, it's common sense. It includes a certain file into your program. Let's talk about using statements. Using namespace std will be used quite a bit to shorten your code up a lot. Using namespace std. And I don't know if that one. Okay. Okay. So using namespace std, we compile it, we run it, and it works. So let's talk about using namespace std and all the using statements in general. Using statements just let the compiler know that you are using a certain coding standard. It basically cuts your coding time a lot. Grammar templates. This is something quite interesting that I was taught how to use in programming. Whatever is between uh, less than and greater than are optional. Also, to make it easier, optional will be in green. C++'s keywords will be in light blue. So remember that. Output. C++ output is count. Count stands for console output, and the way it prints stuff out is weird if you have programmed in Java or C#. It's nothing like you've seen before, probably. What you have is count, that's a C++ keyword, less than, expression, and an optional less than, and L to end line. Now, the way to remember count is that less than is pointing outward. You start for count, and what is the arrow's pointing? It's pointing outward. Starts off with a dot, and then points off outward. So remember, pointing out outward is output. An expression, we'll go into that in a minute. Hello.cpp, your first C++ program. What we're going to do is talk about the coding, walk through the editor, add in an output line, how to add a waiting line. Okay, so let's close this out. Hello.cpp. Hello, just put hello there. Let's do finish. Alright, so if you're using Visual C++, you add another line called include IOStream. And after that, you include using namespace std. And after that, you put int main, oops, open and closing curly braces. We'll get into that in a little bit. Inside that, we need a count statement. Console output. How do we do the less than or greater than? Which one? It's pointing outward, so. And an expression can be a quote. Hello world. An optional, an L, but we'll put that so it does it on a new line. To add a waiting statement, we'll do sin.get. It calls sin's get method and that will wait until you press a key. For every other method except for the main method, you need to have a return statement, unless the return type is void. But since our return type is integer, we should have a return statement. But in the main, we do not need it. In the main method, we do not need a return. If it makes you happier, you can put it. Return 0. Okay, delete this. Compile. Yes. Build it. F5. Do that. We printed something out to the monitor using the CMD prompt, which of course is MS-DOS, but command line. You can get to that by doing start, run, CMD. Okay, so let's walk through the program on the editor. This includes our header file, stdafx.h. You can go into that by clicking this, see what kind of stuff they have in here. So they have 2 includes and 1 define. That's a preprocessor, but that says define this. Define this variable. Now we do include IO stream. So where is IO stream? Yes, so we found IO stream in our program files, Microsoft Visual Studio 8/VC/includes. And that includes IO stream. And we can see what IO stream has by opening Notepad and dragging and dropping it in there. See what kind of stuff it has. There's our sin, there's our count. We'll be using most of those all the time. So it's kind of a mess and hard to understand, even I don't understand most of it. Okay. So these are all of our basic include files, and if it's in this folder, we can have brackets on it. If it's inside that includes folder, like IOStream is, we can have brackets. But since stdafx is not, we had it in our project, we had to put quotes. We'll go into that more later. Use the namespace std that shortens up your program, because without it, you'd have to put std : count. File. No, F5. Yes. Okay. But if we have a user namespace std, we do not need to put that. Yes. It just makes everything simpler. So let's walk through the editor. If you haven't guessed already, it has code completion. So we put sin dot, then we have all the stuff that's in dot. So it has code completion. It has kind of like Microsoft Words or all of Office's error correction, that it'll scan it live for the very basic things. And if it finds it, it will tell you. Like count, hello world. I don't know if it'll catch that or not. No, it won't. Okay. It won't catch everything, but it'll catch the very basic stuff. But everything will be checked once you hit compile. See, let's try that. Compile. Yes. But then we have an error. So that's pretty neat. It tells you what line it's on right here. It's on line 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's on this line right here. And it was an extra less than sign. So code completion is great, and error correction is great. The toolbox, you won't be using that until you get into Windows programming. Let's see here. The you can add the line numbers or any kind of settings you want in the options menu, obviously. And that's pretty much it about the editor. We'll go into more in depth about it later on, but that's pretty much the basics of the editor. This is the Solution Explorer that shows a tree view of your program. You have a solution hello, project hello, and it has 3 folders and a readme.txt. You know, open that up and it'll have a little readme for you. Inside the header files is where we have our stdafx.h. Inside our resource folder we have nothing, but inside our source files we have hello.cpp and stdafx.cpp. So that shows a tree view of our program. And now what we have left to do is close the solution. My computer's lagging up. Okay. Close the solution. Yes. So we covered everything. Talked about the coding, talked about the includes, talked about the using statements. We'll go more in depth about the methods and the main methods later. We added an output line and we added a waiting line, which will wait for the user to press the key before it quits. And we demonstrated that. Now let's talk about an expression. There are 4 things that can be an expression. A constant, which is what we used was a string constant, double quotes, a variable, a returning method, or a combination of the above with math operators in between. Statements are lines of code that can be used for actions. There are 3 types of statements: declaration, assignment, and call statements. After every statement, there must be a semicolon, just like there needs to be a period after a sentence in English. Declaration statement. This is to declare variables. We'll get into that later, but just to give you an overview on the declaration statement, we have X modifier as optional. Type is a C++ keyword, and name is a variable name you want, and semicolon. This will declare a type and name of information, variable or object to be used. Assignment statement is variable equals expression. Assign an expression to a variable. Types of both sides must be matched. And earlier you saw a 2 equals sign, but this single equals sign is the assignment operator. And there we have our expression stuff again. Constant, variable, returning method, and combination of the above with math operators in between. Finally, we have the call statement. This is separated by 2, internal and external. Internal, you just call method name and provide the arguments inside the parentheses. Call a method in the same class to perform actions. External, need object name dot method name and provide the arguments. Just call method in a different class by using an object to perform actions. Okay, that's it for this tutorial. Want to burn you out on the first tutorial. So next tutorial we'll talk about methods, variables, constants, math operations, and operator precedence. In the tutorial, the program uses Microsoft Visual C++ 2005. For more information in the free version, go to msdn.microsoft.com/vstudio/express/visual C, and they will have the free version available for download. Remember, if you download the free version, you download the SDK too, or else it will not work. So that's it for this tutorial. Tune in next time for a long tutorial, probably twice this long. See you then.